The SNAIAD vertebrati, characterized by a solid silicate lens and often complemented by heat sensors, has evolved uniquely, with most species relying on these adaptations rather than enlarged eyes for nocturnal vision. Magnopsids, however, are an exception, featuring grotesquely enlarged eyes with no heat sensors, pincer-like jaws, and unusual first-head anatomy, which evolved from their origins in Auraland but now survive as a few species due to competition from mainland fauna. The three species of Nycticyon are the sole Magnopsid survivors from the Auraland-Asterna population exchange that have thrived in the northern continents. Small, intelligent, and highly adaptable, they inhabit diverse environments and are known for their aggressive nature and surprisingly powerful pincer-like jaws. While they primarily hunt smaller animals found in leaf litter or sprog using their elongated second heads, they occasionally prey on larger creatures like chopsticks. They are also frequent intruders in southern Mediterranean cities, plantations, and even homes in search of food. Despite their modest size and timid demeanor, Nycticyon share ancestry with much larger, now extinct Magnopsids. Fossils from the Yatton beds in southern Auraland reveal massive species like the 4-meter-long Murderognathus, showcasing the formidable predators their lineage once produced. This shy hunter of small prey hardly lives up to its fearsome names. Early explorers in Auraland were first alerted to the presence of Infernocean by its piercing, stereo-like screams echoing through the night. The reflective glint of its enormous eyes was often mistaken for those of far larger predators, fueling myths of monstrous beasts. These tales only faded when camera traps captured the first images of the elusive creature. During the day, Infernocean hides at the bases of Auraland's distinctive bulging pinnacles, emerging at night to hunt small animals on the Gallery Plains. Phylogenetically, it and its relatives are more advanced Magnopsids compared to the primitive Nycticyon. With elongated legs for running and slender skulls optimized for grasping small prey rather than crushing through tough material, Infernocean is among the most harmless and timid of the large SNAIAD predators. This is the largest Magnopsid species still in existence. Dwelling in the dense forests of Auraland's peaks, these elusive creatures primarily feed on small organisms found in leaf litter or burrowed within trees, which they capture with swift, scissor-like snaps of their machete-shaped jaws. They also frequent forest streams, preying on arthrognathan river snakes and bugs almond. On occasion, they follow these waterways into the Auralandic plains, where they fish under the moonlight, their vast, reflective eyes glinting eerily in the dark. Extremely rare, their total population is estimated to number only in the tens of thousands. Further study is urgently needed to unravel their secretive habits and assess whether their population is stable or in decline. Losing these enigmatic creatures would add yet another name to the growing list of magnificent yet vanished Magnopsids. Commonly called cowbirds, the bizarre Anomaloplopods are foraging omnivores that evolved when Auraland was an isolated continent, and spread northward after its collision with the main eastern landmass. These creatures are distinguished by their strange, armored hind feet clad in a sheath of dermal bone. These consolidated limbs give the Anomaloplopods great strength, be it for digging, hopping, and kicking their would-be predators to death. The red cowbird is a lazy browser, feeding on anything it finds. The prey items are caught with the long, sword-like beak and tucked into the chest mouth for ingestion. They are one of the most vocal animals on SNAIAD, communicating with strange, oomph sounds made by the stereo mouths on their front feet. SNAIAD animals possess specialized second heads for feeding, ranging from simple structures with prehensile tongues to complex appendages adapted for tearing and grinding plants. Among these, Heterostomes are rare and highly specialized herbivores, likely the remnants of a once diverse group now largely extinct due to competition from advanced herbivores and predation by efficient predators like futoders and cahedrons. Once widely used as draft animals and mounts during SNAIAD's early settlement period, orca runners remain among the planet's most iconic creatures. Even in modern times, they are favored for sport riding, contributing to their spread across the Neo-Mediterranean basin, where they live both in the wild and in captivity. In their native notor, orca runners inhabit the transitional zones between sprogland, forest, and erythrophyte scrub, feeding on bushes and low trees but avoiding sprog itself. Highly social, These herd animals dominate their home plains and defend themselves against predators like Notorian rapists and dromaeohydrons with powerful kicks and their bark-like hip armor. Their domestication was pioneered by Mila Ssis Erdem during SNAIAD's early colonization, aiming to compensate for the lack of machinery. Despite attempts to tame other species, such as allotaurs and numagazelles, most proved too aggressive or difficult to manage due to the intense evolutionary competition in mainland ecosystems. Orca runners, shaped by the more tranquil environment of Glacianodar, emerged as ideal candidates for domestication. In the mixed green and red scrublands of certain Westernian highlands, the towering tail stalks of male thaumaturus stand out like waving electric poles. These peculiar structures, remnants of an ancient sexual armaments race, are used for territorial displays and dramatic ritual fights between males. While the tails make them highly visible to predators, most males lose them to accidents, fights, or attacks shortly after the mating season. Despite the increased risk of predation, the chance to sire offspring outweighs the dangers. In contrast, female thaumaturus, lacking the extravagant tails, bright colors, and long beaks of the males, live in cohesive harem groups dominated by a single male until he is replaced or dies. Thaumaturus belongs to a heterostome lineage once filled with lightly built, swift-running species that roamed SNAIAD. Fossil evidence shows that the exaggerated tail stalks of modern males evolved from the counterbalancing rods of their agile ancestors. Over time, this lineage shifted to a slower, browsing lifestyle, while their fleet-footed relatives disappeared. The windy crags of the Pontic Alps are home to one of SNAIAD's most extraordinary creatures. With elongated foreclaws, beaks, and dorsal and ventral ridges adorned with stick-like spines, spinies resemble living pincushions bristling with javelins and arrows. These shy animals are difficult to study due to their sparse distribution and elusive behavior, but they are often recognized by the eerie rattling sounds they produce by clashing their spines together. This haunting noise is accompanied by a low, stereo wail emitted from breathing orifices located in their armpits, a feature common to many terrestrial SNAIAD vertebrates. The exact number of spiny species is unclear, with populations on nearby mountain plains classified under the genus Spinodesmus. A distinct group of large, black-bodied individuals living alongside S. avancna may soon be identified as a separate species. Regardless of classification, all Spinodesmus species subsist on select mountain vegetation, and females appear to give birth to a single offspring annually. Both males and females share the impressive array of spines that define these enigmatic creatures. The hulking, armored Allotauriformes dominate the large herbivore niches on SNAIAD's mainland continents and are among the most diverse advanced herbivore lineages. Characterized by powerful second head mouths, protective skin armor, and semi-flexible boot-like rear appendages, they are tentatively divided into Archaeotaurids, with larger front legs and less efficient feeding heads, and Hesperotaurids, with more balanced gaits and compact second heads, though recent studies suggest these groups may be polyphyletic. Not all Allotauriformes are towering giants. The western suitors, or pig bulls, are among the smallest members of this diverse lineage. These 5 species, including the aptly named Polylophosaurus, live in burrows dug with their spade-like first-head beaks, emerging during the day to forage on wetland plants, fruiting bodies, and a variety of other vegetation. When threatened, they retreat to their burrows, using their spiny hindquarters to block the entrance. Their distinctive feature is the abundance of armored skin folds running across their backs, providing additional protection. This distinctive small allotaur is easily recognized by its brightly colored dorsal armor and the exceptionally long, antifutator horn that extends from its rear. The horn, which grows throughout the animal's life, is often broken and regrown due to near escapes and accidents, and serves both as a defense against predators and a social tool. Mating pairs have been observed using it in ritual combat, and individuals in the jungles of southwestern Esterna bang their horns against hollow trees to communicate across the misty darkness. 2 separate populations of this species exist, one in southwestern Esterna and another in Midland. It remains unclear whether the Midland population was already present before the land bridge to the main continent submerged, or if they arrived later by swimming or rafting. Further studies may eventually classify the Midland population as a distinct species. This massive creature is the longest, if not the heaviest, of all known Allotauriformes. A gentle herbivore, it feeds along riverbanks, forest edges, and even pinnacle ranges, favoring a mix of bushy red and green plants over sprog. Barotaurus is distinguished by its extraordinarily long second head neck, supported by a first head that functions like a suspension bridge, resembling the titaniforms of distant Thalassia. While it moves easily on land, it is occasionally seen wallowing in deep rivers or even the sea, where its unique barrel roll swimming motion, necessary for breathing due to its armpit-located breathing orifices, is part of its mating ritual during the warmer months. Barotaurus longus is the sole species in its genus and was once classified as Allotaurus titanis, as it shares many traits with the three Allotaurus species. Unlike its Allotaur relatives, Barotaurus does not migrate or live in herds, relying on its immense size for protection from most predators. However, young individuals are vulnerable to attacks, as seen in the pictured animal, which bears scars from a past assault by an unknown Futurtoriform. A larger, possibly related creature is rumored to inhabit the Great Azonic Jungle across Westerna. It is a curious coincidence that the first observed and most widely recognized member of the Allotauriformes is actually an exceptionally atypical member of the group. Known for the striking golden hue of its leathery armor plates, this species features exaggerated forequarters and an enormous second head, which serves as a powerful feeding tool capable of stripping large patches of sprog down to bare ground. To support this massive head, the front legs are large and tractor-like, and they are also used for defense. A single stomp from one of these limbs can easily crush even the strongest SNAIAD predators. During migration seasons, this species, like many of its relatives, takes part in the vast megaherbivore migrations between Esterna and Westerna, accompanied by a range of predators, commensal species, and parasites. This colossal creature is distinctly different from all other Allotauriformes, leading some SNAIAD zoologists to classify it in a separate group. Unlike other allotors, which have long necks and vat-like grazing organs, Chasmataurus features a thick, muscular, shortened mouth, similar to those of the Xenosuids. Its diet also sets it apart, as it includes not only tough, indigestible vegetation but also scavenged meat. On one occasion, a Chasmataurus was observed trampling and consuming parts of a defenseless Loplophids. In terms of allotaur evolution, it represents a shift from the typical herding herbivore behavior to a more solitary, omnivorous lifestyle. Though widespread, Chasmataurus has a sparse population scattered over a vast area. Its rarity, coupled with its aggressive nature toward intruders, makes studying these animals particularly difficult. This species is one of the more unusual allotors, characterized by leathery plates that have hardened into 6 sideways projecting spikes, and a peculiar, saw-toothed crest that extends forward from the top of its first head. Its defenses are further reinforced by a backward-pointing horn on its rear, serving as protection against attacking futures. While the rear and side spikes are consistent across most individuals, the head crest shows significant variation. In some, it's barely noticeable, while in others it grows to an exaggerated size that may seem impractical. Both sexes have crests, but the largest ones are found on the males. This relatively small allotaur lives in family herds of up to 10 individuals, with mature males typically leaving the group to seek mates independently. Interestingly, certain feminine males in these herds have very small or no crests at all. These individuals have been observed infiltrating other herds to mate with females before quickly fleeing. This is a fairly typical example of a Hesperotaur, if the term still holds any relevance. Like their relatives in Esterna or Pansavanna, these large herbivores move in massive herds across the sproglands and plains of their territory, grazing continuously. Their long second heads allow them to consume both sprog and vegetation from trees. Unusually for Allotauriformes, these animals sometimes engage in pinnacle probing, where they crash into pinnacle tree reefs in local ranges, feeding on the vegetation within. 3 large spines along their neck, back, and rear provide protection from predators both inside and outside the pinnacles. This dainty herbivore belongs to a line of lightweight grazers with powerful, jumpy hydraulic musculature, the Pneumopodids. These animals have extensively developed a system of quick-firing, cushioned hydraulics and hoof-like limbs that allow them to bounce and skip gracefully in their escapes from predators. Numagazella midas is one of the commonest of the 20-odd species of gracile pneumopods, easily recognizable in the field with its elegantly curving upper beak and reddish color. In warmer months they form vast herds that sweep the western continent from end to end. These annual migrations are followed enthusiastically by a diverse assemblage of predators. These imposing herbivores are native to the plains and pinnacle ranges around the Skoptic Delta, where they spend solitary lives, coming together only to mate. Although they look like twisted allotaur relatives, the Gnathonychids are in essence scaled-up nemagazelles, having adapted to their large herbivore niche in the last 10 or so million years. Temperamental herbivores, the Jorinos wield their jaw horns with unnerving accuracy, so even pack-hunting missionaries think twice before attacking them. Unlike terrestrial rhinos, Jorinos don't simply charge. They gallop towards perceived threats in terrifying burst of speed, before loping off heads or limbs night-style with their flexible necks. In recent years, Jorinos' victims have begun to include a distressing number of tourists, who usually fail to take heed of its boisterous warning displays. The gigantler is a massive herbivore that lives in what could be considered forested areas. It is a slow and heavy animal with a measured and surprisingly delicate gait. The group of Tragolarhynchids to which it belongs is a questionable taxon that also includes Pneumopodids and Gnathonychids, all of which are equipped with hoof-like structures and pneumatic muscles in their legs, allowing for great flexibility. The gigantler is large enough to have no natural predators, with only the young being vulnerable. These animals are solitary and leave their offspring alone, with the young spending their first years hidden in the dense, spongy vegetation of their environment. The gigantler possesses a large horn at the front of its lower jaw, which it uses to manipulate the vegetation it feeds on, while males also use it during mating or territorial fights. Hoploderma is an archaic herbivore with a naked, proboscis-like second head instead of the more developed, muscular chewing machines of modern grazers. It has survived thanks to its relative's geographical isolation on Glacianodar, and its specialized diet of high-growing fruits and shoots. Although warm-blooded and descended from running ancestors, the turtle tank is secondarily sluggish, its splayed legs not good for anything more than a rapid walk. It protects itself from the attentions of predators with its tough, spiny hide and bizarrely, nerve gas. The leathery shell is surrounded by two sphincters that release a colorless, evaporating fluid. If breathed in for too long, it can be lethal to SNAIAD animals. In people it causes anesthetic effects. It is thought that this method of defense evolved from stink glands analogous to those of earthy skunks, but the pressures that caused the evolution of such a lethal defense remain unknown. Like most animals of Glacianodar, the hoplodermids seem to have suffered the attrition of unknown, deadly predators at some point of their natural history. The small, plump, muscular fattails are the vague equivalent of pigs and boars on SNAIAD. Unlike the many species of migrant herbivores, they stay in the same location year-round, feeding on any vegetation available. Always resourceful, they have evolved the most advanced chewing adaptations seen on any herbivore, to such an extent that their primary heads play no role in feeding. Instead, the jaws have contorted shapes and are used in defense and display. The roll pig, like most xenoporcids, bears a huge fat reservoir on its tail. This organ can be shed explosively when the creature fights for its life, showering its would-be hunter with goblets of fat. It must be noticed that this is a truly desperate measure, since loss of the food storage might mean starvation for fat tails, especially in the lean seasons. One of SNAIAD's unique evolutionary features is the development of jet-propelled vertebrates in its rivers and seas, a rare adaptation seen in large animals descended from terrestrial ancestors. This adaptation involves significant changes to the SNAIAD body plan, including the rerouting of the digestive tract for propulsion and the use of the first head's jaws as true mouthparts for feeding. True Jetocetes have more advanced jet propulsion systems than the phyllocaudids or motosuchids, but lack the heart-like pumps found in Cardiocetes. Their digestive system has evolved, with part of it forming a jet pump for continuous flow, while the rest has fused with the jaws on the first head, allowing them to feed using their first heads, a unique trait on SNAIAD. Despite facing fierce competition from the formidable polycardiac Cardiocetes in open oceans, many Jetocetes still occupy mid to large predator roles in shallow waters and reef environments. An example of this is the Mediterranean jet's-hark, which, possibly a subspecies of the airite jet's-hark, resides year-round in the Neo-Mediterranean and preys on creatures smaller than itself. Though rare, jet's-hark attacks on humans have prompted public beaches to issue alerts during busy days for safety. While the Cardiocetes include some of SNAIAD's largest filter-feeding species, the more traditional Tragolarhynchid Jetocetes, like Heterostomes, actually have a greater diversity of species and biomass, particularly in colder climates. Ranging from just over 2 meters to 13 meters in length, these creatures hunt plankton and various pelagic swimmers in the SNAIAD seas. Well insulated by thick layers of blubber, Heterostomes balabani are frequently seen in the Great Northern Ocean, traveling in family pods of up to 100 individuals. However, they are preyed upon by two species of aggressive torpidicthiid polycardiac Cardiocetes that inhabit their range. Found throughout SNAIAD's oceans, the over 30 species of thalassoxophid swordfish are among the fastest creatures, rivaling true Jetocetes. These animals feature compact, egg-shaped bodies equipped with efficient water jets, but lack the heart pumps found in Cardiocetes. Interestingly, they possess well-developed rear fins, which may seem odd for streamlined swimmers, but these fins actually help direct their water jets at sharp angles for enhanced maneuverability. Although it might seem that thalassoxophid Jetocetes would be outpaced by the incredibly fast polycardiac Cardiocetes, the two groups coexist in most marine environments. The Cardiocetes tend to hunt more energy-rich prey due to their high metabolism, leaving the thalassoxophids to feed on less nutritious options, which they can thrive on without the constant risk of starvation when fueling their water jets. Thus, both groups manage to occupy the same ecosystems by exploiting different food sources. Motosuchid jet crocodiles patrol the large rivers of SNAIAD's continents, gliding through the water with eerie stillness, propelled by their gastrointestinal water jets. Ancient and mysterious, these creatures occupy an evolutionary intermediate stage on the path toward fully marine jet-powered swimmers. The motosuchid digestive system has partially split into two sections, one for processing food and the other acting as a propulsion tube. Despite this adaptation, they cannot drink salt water, and their jet propulsion isn't strong enough for continuous movement, limiting them to rivers and isolated lakes. However, they have mastered this niche so well that fossils from 40 million years ago are nearly indistinguishable from modern species. The Ein scooter croc, native to the Skoptic Delta, is named for the prominent, staring dorsal eye spots that resemble ancient ship decorations from distant Earth. Its hooked beak is well suited for both bottom digging and swift lunges at unsuspecting prey. Its enlarged jet gut allows it to release powerful 5-second bursts, propelling it rapidly toward terrestrial victims, who rarely even realize what struck them. When this creature was first discovered off the Sea of Midland 50 years ago, it caused a stir in SNAIAD zoology. No one could quite figure out what it was or how it used its strange, ram's horn jaws, which bore a striking resemblance to the Helicoprion fossils from distant Earth. However, research over the following decades has finally clarified its lifestyle and origins. Originally believed to be an unusual motosuchid, Helicodex was later identified as a specialized Jetocete that had secondarily lost its torpedo-like body shape and reduced its jet propulsion system to pursue a unique diet of sea serpents found in SNAIAD reef gardens. Helicodex has been observed moving slowly along the reefs, using its tail for propulsion rather than its jet gut, and its peculiar jaws are perfectly suited for capturing the serpentine bodies of sea serpents. Even after unveiling its secrets, Helicodex serves as a reminder that SNAIAD remains a mysterious world, full of strange discoveries and awe-inspiring creatures. This species, along with its close relative Phyllocautus flagellurus, belongs to the most primitive group of jet-propelled swimmers. The reticulated oartail is found exclusively in the Oceanic river system, where it feeds on vegetation and small riverine creatures. It primarily swims using its powerful tail and paddle-shaped fins, but when threatened, it can quickly expel water from its anal sphincter to create rapid bursts of speed. Unlike other groups, phyllocaudids lack a specialized section of their digestive tract for jet propulsion. Instead, they swallow and expel water quickly. This method of locomotion is not ideal for them, as it causes them to lose all their stomach contents and go hungry. These ancient creatures are rare and their numbers are believed to be declining, prompting the initiation of captive breeding programs to prevent extinction. While the Jetoceted Cardioceted line of evolution might seem pretty straightforward, there are creatures on SNAIAD which remind the observer that evolution always works through a series of branching radiations rather than a singular line of descent. These three groups, although clearly jet-propelled swimmers like the Jetocetes and the Cardiocetes, bear unique traits that make them impossible to be classified comfortably as members of either groups. This species, along with several closely related ones, forms a ring species complex around the polar continent of Glacia. Though they resemble true Jetocetes as fast, cruising predators of smaller marine life, they differ in having breathing holes on their necks and unique accordion-like jet guts, a feature unmatched in other jet-propelled swimmers. Despite the ability to use their jet guts for a speed boost in emergencies, Nymphocetus and its relatives rarely rely on this adaptation, instead favoring their muscular tails for propulsion, likely to preserve body temperature and protect their internal systems from the icy waters. The 2 or 3 species of babafingos exhibit a perplexing combination of traits found separately in Cardiocetes, Jetocetes, and their ancient ancestors. Similar to Jetocetes, they have a distinct jet tract without heart-like pumps, but their breathing holes have shifted from the shoulders to the neck, like in Cardiocetes. The most striking anomaly lies in their limbs. Unlike the atrophied fins of other jet-powered swimmers, babafingos have jointed paddles that allow them to crawl along the seafloor and manipulate food. Whether this trait is an ancient, retained feature or an unusual atavism remains a hotly debated topic in SNAIAD zoology. Babafingos lead peaceful, uneventful lives, foraging in warm, shallow waters for underwater plants and bottom-dwelling animals. Though slow swimmers, they can defend themselves by releasing large amounts of black, slimy ink from a gland linked to their jet tracts, effectively choking predators. The vermicidids are a group of jet-swimming creatures that are as unusual internally as they are externally, living in the deep abyss of SNAIAD. Though they initially resemble Cardiocetes, their heart pumps form an odd chain of 12 to 16 hearts, whereas even the polycardiac Cardiocetes have no more than 6, arranged in a radial, engine-like pattern. Despite having multiple jet pumps, Vermicides does not use them for swimming. Instead, the hearts act as buoyancy chambers, controlling the animal's depth by retaining or expelling water. Adding to their oddity, vermicidids have rear fins unlike those of true Cardiocetes, formed from skin and muscle puckerings with no bones inside, prompting debates about their primitive versus derived traits. Currently, only 2 species of Vermicides are known, both of which hunt deep-sea swimmers in the dark depths. Given their elusive nature, it's likely that many more vermicidid species remain undiscovered in SNAIAD's unexplored abyss. Cardiocetes are the pinnacle of jet propulsion evolution on SNAIAD, building on their Jetocete ancestors with a specialized propulsion system powered by a powerful heart-like pump. Due to the high energy demands of these pumps, most Cardiocetes have evolved into filter feeders, relying on plankton-rich ocean currents for sustenance. Polycardiac Cardiocetes are among the most energy-intensive swimmers in the SNAIAD oceans. While some, like the massive biogallias, feed on plankton swarms, others, such as tachinas and their kin, target smaller swimmers. A small subset of this group has taken their predatory behavior to a deadly extreme, actively hunting and feeding on animals larger than themselves. Often referred to as jaws with a jet engine, these creatures are known to take down even the largest of SNAIAD swimmers, including Blumbomeniformes Jetocetes, blamos, giant Cardiocetes, and sea serpents. Although they occasionally attack open sea vessels, they pose a far greater threat to swimmers in open water. Thankfully, they rarely venture into shallow seas like the Neo-Mediterranean, making human encounters uncommon. Not all polycardiac Cardiocetes are slow giants like the biogallias. In fact, most are much smaller and live more like aquatic swallows to support their high-energy metabolism. The 30-plus species of tachinas are swift, pelagic predators that hunt small swimming creatures like swimming centipedes and sea serpents. Equipped with 6 jet hearts along their jet tracts, which function like engine cylinders, they expel water rapidly, making them some of the fastest swimmers on any human-inhabited planet. They can leap out of the water, perform acrobatic maneuvers, and pursue their prey with incredible agility. However, this energy-intensive propulsion comes at a cost, as their rapid metabolism leads to frequent starvation and short lifespans. Recently, some species, like Tachinus tachino, have been observed using a form of supercavitation, creating an air bubble in front of their faces while leaping, which acts like a diving mask, allowing them to move even faster underwater. These large Cardiocetes are more often heard than seen underwater, with their pulsating jet beats echoing across the waves. Though they resemble the monocardiac giants of the north, their unique mouth structure, multiple jet hearts, and feeding methods distinguish them as polycardiac Cardiocetes, albeit large filter feeders. Unlike their monocardiac relatives, they actively take bites from massive plankton swarms rather than passively swimming through them. They have also reduced the engine-like intensity of their jet hearts, moving at a more relaxed pace compared to their smaller kin. Biogalia's species are easily identified by their tapered, ram-like snouts, which they use for social behaviors like friendly snout rubbing within pods, mating displays, and even ramming intruders or competing males. There are at least 4 species of biogalias in the SNAIAD oceans, with Polaris species also found in the northern hemisphere. This colorful monocardiac Cardiocete is so similar to Xenoposeidon species in terms of anatomy and behavior that it is debatable whether it really needs to be classified in a separate genus. Like Xenoposeidon, it is a passive filter feeder with a single jet heart. Its striking black and white color scheme, as well as its brightly orange head, makes it a favorite of sea watchers around Aviv, Alcott, and Elliot, the only settlements along its habitat. One of the largest creatures on SNAIAD, Xenoposeidon thalassarcos, is a truly awe-inspiring sight. A monocardiac Cardiocete, it possesses a massive, singular jet heart at the end of its propulsive gut, which helps it reach bursts of speed, but it also relies on the motion of its immense body to glide through the water. These creatures constantly travel with plankton-rich sea currents, living in streams of tiny marine life. Their expansive beaks contain a complex system of shunts, inlets, and holes that efficiently filter water for nutrients. The same holes, which expel the filtered water, also play a role in reproduction. During mating, males release a thick, ink-like substance from these openings, which females willingly immerse themselves in, later becoming pregnant. During pregnancy, the developing young occupy the female's mouth entirely, and she receives nourishment from plankton processed through her jet tracts and jet hearts, which originally evolved as part of her digestive system. Blumbomens and their relatives are part of a clade marked by the fusion of their first 2 heads into a humanoid-like face, and the presence of a facial pouch, which serves different functions in males and females. Most Blumbomens are awkward on land but agile swimmers, using their muscular second heads to capture prey or search for organisms in underwater plants, with some species feeding on marine plants seasonally, and they are likely closely related to the Pechidont bumbos based on shared physical traits. The Blumbomen lineage includes at least 2 major radiations that have adapted to a fully aquatic lifestyle. One of the larger groups, the Blumbomeniformes, is represented by Thalassomerophex and its relatives, which feature extremely elongated second heads that can no longer retract into their bodies, giving them a distinctive appearance resembling a mix of mesoplodont whales and the extinct elasmosaurs. Thalassomerophex is an opportunistic predator, hunting pelagic creatures and diving to great depths in search of prey, though much about its life and potential species variations remains unknown, with further discoveries likely to be made in SNAIAD's oceans. This species is part of a different fully aquatic branch within the Blumbomeniformes, separate from the Blumbomeniform swimmers. The presence of a protective face pouch is believed to have facilitated the transition to marine life, allowing these creatures to carry their young underwater. Apodoblumbomeniformes, such as Eumegapteros, are characterized by the absence of rear legs, the extensive development of forelimbs into powerful fins, and well-developed eyes for prey detection. They resemble land-dwelling Blumbomen, but without feet, and with large heads and binocular vision. These creatures either forage among aquatic vegetation or chase prey, using rapid lunges from their second heads to capture them. During mating, male Eumegapteros exhibit a peculiar behavior where they chase females and launch their genitals, resembling harpoons, from their primary heads. These long, stalked sexual organs are tipped with finlets that steer them towards the female's genitalia with remarkable precision, a behavior recently captured with high-speed underwater photography and dubbed torpedo caster. The genus Eugrops, known as the spectacular Blumbomen, includes several closely related species found along the shores of Vesterna. These creatures are easily recognized by the extravagant fleshy growths on their faces, which range from large, wart-like lumps in some species to long, flowing tentacles in others. The exact purpose of these growths is unclear, though they are believed to be used for sexual display, as both sexes have them of similar lengths. It is also speculated that they may help break up the creature's silhouette underwater, though the considerable drag they cause raises questions about their effectiveness as anti-predator features. Despite their bizarre appearance, Eugrops and their relatives are closely related to more typical Blumbomen, like Moranops, with some species sharing nearly identical skeletal structures. However, Eugrops have longer, stronger hind limbs and spend more time on land, with reports of them even hunting small land animals, though this is likely not common behavior. The specimen shown here displays the large, elaborate male genitalia typical of most Blumbomeniformes, which are often used in striking mating displays. The adaptive radiation of established body plans in isolated environments is a well-documented phenomenon, and it has occurred within the Blumbomeniformes as well, most notably with the fascinating giant armless Blumbomen of the remote island of Mapag. Unlike most of their relatives, these creatures are entirely terrestrial, venturing only into swamps and secluded beaches for drinking and resting. They feed on a mix of terrestrial fruits, small animals, sprog, and beached carrion. Their immense size, combined with tough head scuts and the ability to expel stomach acid under stress, offers protection from predators like the brute turtles. While neither the moai nor the brute turtles are particularly efficient in their roles as browsers or predators, the absence of any other large species in the isolated ecosystem of Mapag ensures the moai's continued survival. The genus name of these creatures was inspired by the monumental moai statues of Earth, sparking significant debate about whether propagating Earth myths was appropriate on SNAIAD, where a return to Earth is not feasible. A captive colony of these charming creatures has been established on the island of Hania in the Neo-Mediterranean. The image shown here features a female moai with a juvenile nestled safely in its bulbous, nose-like genital sac. Moranops is perhaps the best-known, typical Blumbomen on SNAIAD. These noisy beasts form massed communities on beaches within their range, feeding on numerous marine organisms they catch by swimming or kelp browsing, probing underwater growth with their hose-like secondary heads. Their stubby legs make them some of the least suitable of all true Blumbomen for a terrestrial lifestyle, but they still retain archaic characteristics like the claws on their fins. Moranops is the archetypical organism that comes to mind when one thinks of Blumbomen on SNAIAD. This species is part of a unique group of eniciform Blumbomen that are more specialized for marine life than most of their relatives. They have lost many terrestrial traits, such as robust hind limbs and fin claws, instead developing larger fins and a thick layer of subcutaneous fat that provides insulation underwater. These Blumbomen spend the majority of their lives in the sea, returning to land only for mating. Each summer, large groups of these small Blumbomen gather on the beaches around Izmir to mate, creating a spectacle of genital displays and loud mating competitions. After fertilization, the females carry their young in genital pouches, giving birth in the sea. It is believed that these land-based mating gatherings are evolutionary remnants from their more terrestrial ancestors. Like most eniciform Blumbomen, Micri is confined to shallow, warm waters year-round, with a very limited range. Izmir's proximity to their breeding sites places additional pressure on their populations, leading to their protection as one of the city's symbolic animals. During the mating season, Izmir's beaches are closed to visitors to help preserve the species.